So let's start off. Obviously, yeah, the topics to today is Keras CV for the young and restless. So we kind of give you kind of a computer vision workflow around it. And so let's get into it. And talking about me and so what we will tell then in the next slide around it.
Co-organizer for GBG Mat. So just like Chhattisgarh, if you're around in Mumbai, well, you should absolutely attend our events. We have events every month or so with NefFest coming up on 9th over here in Bombay. So if you're around, absolutely you should come by. I'm also an XML research engineer intern at Ivy, and I'm currently a final year student at NMIMS University in Mumbai. I was a GDSC lead before in 2021, and in my free time, I'm a Barcelona supporter. So, yeah, that's me.
Yeah, thanks Suvaditya for that. And yeah, I guess my basic intro. Obviously, I already shared. So right now, I'm an associate open source license at Kote. I'm also one of the contributor TensorFlow during my GSOC time. I contributed in TensorFlow.js project. I'm an ex-developer advocate at Postman. I'm also a developer intern at Turing. And in my freshman year, I also an ML intern at a startup called GoBasket. And I'm a GitHub campus expert, and you can say ex-Gold MLSA and post-management leader for the student being for that part. But yeah, let's jump directly right into it. So today, these are the kind of a roadmap we will cover off. So we were starting this thing with what is computer vision. If you are people new and didn't know about in general about computer vision or deep learning around it, we will try to kind of a kind of a get into dig around it and share the 10th part with you. So computer vision is just CNN and deep learning. Generally, like when people go in the mathematical aspect to it, like everyone will get a understanding around it. Yeah, computer vision is just only CNN and deep learning. But apart from it, if can give you a better view or application point of view of computer vision, think like computer vision just like your eyes, like what you're saying. So right now in front of me, I have a laptop, I have a keyboard, I have a mouse. So after like from if I will say from my birth, I didn't know right what is laptop, what is keyboard, or what is mouse. So maybe through my parents and through what I am seeing through my whole year, you can say around 20 to of thing, I understand that these if this kind of object returns, so it means like it's a keyboard, it's a laptop, right? You are. It's not like that from birth only. This is laptop. Like people tells you, or maybe your parents tells you, like this is what like kind of that. Cool. So that's the whole scene behind. If I can give you a basic understanding about computer vision, think like when we say computer vision, just replace computer with human vision. And obviously, we're comparing, or you can say take an analogy about the you can say human vision around it. That's why I'm just giving you a bit around you can say an analogy around it. But it's like kind of the same. That's what the work on the principle around it. Cool. So yeah, what actually computer vision does. So if you're seeing a picture in left, it's kind of a blurry, right? So right now, computer vision have a so much around power. It basically convert this thing into basically converting into a better picture, you can say bright picture, or you can say there is also if you take a picture in a very dark zone, there is a computer vision model I am guessing called mirnet, and you can basically scale up the whole thing around it, and the picture is really, really clear even though if you're taking a photo in dark areas around it. You can obviously test it out around it. So I'm just giving you an example how the powerful this computer vision is. And again, just think computer vision just like a human vision. But here on a if you say on a human vision perspective, we can't. You can say we can't change the image right in the real world or what we are seeing right now. But in the computer vision, it has a power to basically if any input image we are taking from maybe any system around it, but we can make it more better throughout the whole you can say deep neural network kind of part of it, right? So obviously we are not going into that obviously, but just giving a brief. So yeah. So before that, obviously, you pretty much know about like people say in the previous one like computer vision can't do anything and like they can do everything, but for the basic one they are reiterating around the bigger problems around it. So yeah, but like about object detection kind of thing, you can say segmentation kind of thing around it. Like so, yeah. So that's why when we say so computer vision and deep learning go hand in hand, because again, how you will implement that stuff, right? So again, to understand your network. So suppose giving you a small not a kind of a overlay of about the concept behind object detection. So from if you are a baby, right? You were just birth maybe last month, right? And you didn't know about any object. So if my mom tells me suppose if I see a bottle, okay, but I didn't know what it is a bottle or not. But my mom is telling me like on every day, every month, this is bottle, this is bottle, this is bottle. And suppose in the ecosystem, if there is a bottle, but my mom tells me it's a car, like 5 years, 10 years. So even though in a generic sense in my brain it tune up like it's called car, right? Because I am tuned with and the my you can say from my childhood, like I'm tuning up like it's called car, but in general people say it's more a bottle, right? So the point I'm here to referring is from the whole duration of your starting birth, you can say, ki like uh, you're just referring, you're training the, if you will say, if you are a parent, if I have a baby, I am training them. So same thing with the you can say machine computer vision, or you can say machine learning in general also. What do we do in machine learning? We obviously train the data, and data is here experiences, right? So experiences, I can tell maybe there can be small experience around it. You are opening a bottle, but over that period of time my mom is saying you are opening a car. So what get into in my head, like this object is called car, even though everyone is says bottle, but it at the end of the day, what are you you can say training, you're training your experiences. So again, it's really important what data you are training. When we say in machine learning, data is really important. Yeah, it's really important what kind of your training you are doing. That's the major crux around it, if you will say, right? So that's why another part is, we got the application, like this is the analogy we are thinking for the computer vision. But how it goes deep learn how it goes hand with deep learning. Obviously we are not digging into deep learning right now, obviously, because our major concept is here to tell about you computer vision and basics around it. So think like we have a machine learning, but leave deep learning. Obviously I have a same thing that, like, for computer vision, it's an analogy of like convert, like you can taking a inspiration from human vision. But for the deep learning, it's coming from the vision of, you can say, or difference from neural, you can say human brains, neural, right? Neurons kind of thing, the same architecture that we are going through. So the same thing that we are trying to process, we are taking a consideration of human parts and making it to more artificially, so that you can basically use you can do, you can say, kind of do those kind of activity, but in a more better way, right? That's our, you can say, major motto behind it. So again, that's why I'm saying best of all worlds. Traditional, or like if you're saying on the right side, the meme, obviously, like for that. Yeah. So so next part we are covering around the convoluting your way into CV. Cool. So obviously, those who didn't know, I just give you a small brief around it. So obviously, images are at the end of the day are matrices only. Like, simple thing. And if you say about the video thing, it's just like images per second is translating. That's the thing. You can the frame per second. That's what we say, right? And we say about video, but let's talk about the art. So the thing is, you can say see a lot of what I can do for you, just to, I know it's not a total you can say around that kind of session, but I can give you one. Just let me know my white screen is visible to you, or I guess it's visible. Yeah. So what actually I'm sharing with you here, so think like that. So suppose this is a matrix. I'm just creating a box. And it's really sorry for my writing, it's just I'm explaining for you. Good. And suppose its value, I'm just passing any random value, 7, 23, 1, 4, 6, 9, maybe 2, 1, 77. Okay. Okay, so this is the value of a matrix that I'm providing. So when we say convolution, it's just what if I will take a part of it, the nearby cells of it, right? If you consider this part, 6 1, so the convolution will be created from this to the nearby cells out of it, because the convolution is generally what I prefer to around it. Like it's just like the combination of the nearby features. So at the end of the day, when I say values here, right? And we said, let me go, give me a moment. Yeah. So if you will say, if you are want to say this is a thing which values came here. So these are the features 1 23. So it depends on the, if I suppose if we are going for the RGB value, that is starting with 0 to 255, I will say. So these are the features at the end of the day. It's close to black, maybe. Kind of. So I'm doing that in, basically I'm giving a reference around it. Basically, what actually, I'm not going into the mathematics around it, how it goes actually, but just giving you a basic reference out of it, how it does, right? And when we say convolution, it's just basically taking a small part, taking a feature out of it. I'm not obviously not going into the mathematics, how to create, how to calculate it, because it's not a total computer vision session. I'm just giving a basic reference how it totally works. And for the kernels part again, if you will see, like, let me give you a more better context around it. So there's a big matrix. Suppose 1 2 3 4 and 5 6. Same thing. 1 2 3 4 and 5 6. Okay, so we have a 6 by 6 matrix. Suppose if I'm taking this consideration, and these are the kernels, basically you can say around where the basically application is happening. And for the contours part, basically which are you living. So suppose I am just using these parts, only these parts, you can say, right? These are the basically we are doing, and the rest one is the contour part, but these are the kernels part. Basically it's incorporated in a different way. At the end of the day, each pixel you can see give a kernel around it, and basically it's happening some mathematical application where you are seeing like how you are improving your image, right? That's a scene. Like, we are, again, I'm not going into depth of each and every mathematics, just to give you a reference out of it. So yeah, let's, in a more better way. Just give me a moment. I'm guessing it's visible. Yeah. So basically, it's a pixel-wise product and summation with the respect to the window. That means it's basically the matrix product. You can say, you can say multiplication of a matrix and given around to the product. Basically, you can say. Kernel is a small part of the whole matrix. If I will say, if I will show you a 6 by 6 cross matrix around it, so kernel is just, you think like it's a small part of it. It basically, it's that particular matrix. It's actually doing some operation with the whole matrix. Think like that. Okay. If you are seeing here the small, basically the small matrix, it's a kernel, and the whole the back on the back matrix. Let me give you a more, it is lead as a pointer. Yeah. So these are this, the shorter one is the kernel actually, and this is the main image. So multiplication of both is giving you convolution, different convolutions. You're seeing the values adding around. It's just a multiplication kind of thing. So it is the easiest way to compress an image information, obviously, because you're taking the only the maximum features around it. But what is the maximum feature around it? This is a simple thing, if I can say around that thing. Cool. And obviously computationally effective and easy to parallelize, because obviously we are getting the most highest feature around that particular kernel, you can say, when we are crossing over the with the main image, right? So if you understand, I am just giving you that the same thing, only how it totally works, like one by one. It's basically multiplication doing that, and basically generate uh, you can say part around it, and yeah. Obviously, convolutional neural network recognize the image better than before. Obviously, the reason is being, as I already shared with you, like images at the end of the day is matrices only, right? If you will ever heard about, you can say, there's a data set, is a very basic data set. Maybe it's actually MNIST data set. Yeah, MNIST data set basically. So basically, they have a number of different pixels, right? And your process is to understand, like, this image is called 0, this image called 1, 2, 3. Again, what doing, we are basically taking some of the part, like taking the convolutions, we are adding kernels around it, and we're trying to like which value have a. So if there's a byte value, obviously the range will be 255, or the value of that particular feature will be 255, and if it's a black, it called be zero kind of. So that's kind of stuff basically. So basically, make the kernel learnable instead of leaving it fixed, right? We have to make it learn around it, right? That's why the deep learning came into play. The best learning to do, or maybe in a more transit way, is obviously a deep learning. That's why when we say it's a hand in hand kind of thing. And you can obviously recognize the edge and distinct feature on their own, because at the end of the day, it depends on you. If the value is very zero around it, so you know what is a feature it is nearest to that, right? That's why I'm saying it also tells you about the feature around it, about that particular pixel, if I will say, right? Like how much. And path is learning as a vector space representation. If you are basically going on, when we say in the kind of a VIT, basically visual transformer, right? Again, the same thing happening, how it totally runs back to an, and how we are doing a padding kind of thing. So padding just give you a reference where the whole convolution is there, and the rest matrices, it's remaining, it's kind of a padding. And it's also came into mathematical part, how you can use those features into the convolution part of it. So again, it's a depends on your side, like how much giving, how much padding you have to get 2 by 2. So it's like row and column 2 by 2 kind of padding, where you are not using convolution at all. Basically, that's the scene you can say. Yeah, and basically here what is happening? It's basically this is the part of padding, if you will say this one, and the other part is basically on the learning perspective or convolution it's creating. Cool. Now pay attention. You are going to need it. So obviously I am saying attention. So yeah, this is a basically attention is basically taken from the concept behind. There is a concept in NLP paper. Actually, we all those who are joining our research paper reading regularly, they pretty much know. We have done attention based. Basically, it's a basic of Chat GPT kind of thing. How actually in NLP, how it we tokenize the whole. So suppose there's a word sentence and we tokenize it, each word with some values to that, right? Because obviously you can say computers can't understand letters, right? Words, right? So we have to convert them into numbers so that it can so that they can understand. Obviously, because computer understand numbers, they can't understand letters, kind of thing, right? But to understand them, so what we are trying to do, we are tokenizing the whole sentence of our text, right? And convert into any number, basically. To basically tell them, like, suppose if I say I am Kartikey Rawat, so I have another number, am is given another number, Kartika is given. So obviously they can't understand like what is the meaning of Kartikeya or like that. But from the giving, when tokenizing it and providing it a proper value to it, basically they can understand, right? But how to and it's a really good process to go with. But apart from that, how it helps in images, right? You can see how it helps in convolution part. So the thing is, at the end of the day, again, as I already shared, image is just like a matrix. It's a number at the end of the day. So the if you are basically dividing that thing into different kernels, you can the small kernels, right? You can make it use out of it, right? Same thing with the what I did with the NLP part, right? Same thing. So, suppose imagine have a 10 logs. I'm just giving you a bit to let's build up basic intuition around it, right? So imagine have a 10 logs and 10 corresponding key. Each logs open a certain box. Now, obviously, being chaotic and evil person, I am obviously, or maybe that part. So I mix the key up and give them to you, and your job is to unlock it. So how you unlock it, right? So there's a basic brute force you can apply to it. Key like try it everyone's what actually you can go for it, right? And combination can be 10 cross 10, and you can say, or you can say 10C. You can say 10C 10. What's your preference around it, right? What would this solution looks like? So now the basic, this is the basic integration what I have to put it to on. But if you understand this image, like just remove the color background, and it's just like you can say a dog's photo, if you will see in a more better way, right? So yeah, so now imagine pixel of images as a boxes, locks, and keys, like just comparatively analysis I'm giving here, right? Run the same brute force experiment and like keep trying again, like what is the keys, like take one key and try to with other locks, like the you can say the worst case can be the last lock that I'm trying with my first key will be the worst case scenario, like it takes times around it, it is a like time complexity part, so I'm not going into that obviously. And you're going to focus on the right lock key combination, right? Agar if the lock is opened by in my first time only, that will be better, right? It depends on the combination around it, right? So the instance where you get a right lock with right key, there is where you have to focus the most, obviously, right? And each of the 10 instances for you is where your attention will lie. Obviously, that's the main. That's why I'm just focusing on the attention part around it, right? I know that is neither it's a simple nor it's mathematical. So bear with me around it, obviously, right? So let's understand this thing, okay? So this is a matrix. Cool. This is a matrix. Again, you didn't have to like if you have didn't come to attention research paper kind of thing. So you can go to even I give a talk around visual transformer also where actually I explain around it. So bear with me if you are very new to machine learning or in general computer vision. Don't be scared with these mathematics around it. Just think like this is a matrix. Cool. And what I'm doing, I am basically passing of this basically this matrix, right? And the softmax function. Cool. It's kind of mathematical. Again, I'm not going into depth of each and everything part of it, but yeah, that kind of thing you can say. Cool. And it's basically converting into it's passing into a dense layer. That is the you can say the deep learning layer. And again, as you're seeing here, the quick brown fox over the lazy, and it's passing again and again. This is the basic you can say basic attention model if it works, right? And you can get an output and it again returns and going and going. These are this part basically what we are doing, basically converting and tokenizing it, converting the value in different part, basically, if you can understand in that way. Cool. Yeah. So this is the part, if you will say attention, if you will see this kind of thing, maybe you have seen maybe in the, I can say, this is the heat map kind of thing you can say around it. So yeah, you can so go in converting these part into this and the other part of it. It's basically a part of visual transformer at what we are actually at the end of the day doing is here is to basically give them a reference around how we are using the pixelated image in form of numbers, or you can say more in form of how we are doing in the NLP part, basically. So again, just give you again in case if anyone miss out in that thing, what we are doing, we are taking an image, okay, dividing that image, or you can say in a better way to understand you, we are taking some if there is you can say um 3 by 3 image in a matrix form, obviously. So the initial top level part, we are taking a feature out of it, second part, third part, like this kind of part, and we are trying to use it in that way, basically, to tokenize in that manner, basically. Cool. And yeah, going into three lift and pool with the Kera. So I guess this part will be from Suvaditya. So I'm not getting into there, but I am stop sharing my screen, and I guess Suvaditya can add to it if he wants to add. Yeah, and he can start from his top. Yeah.
Sure, sure. Thank you. Right, let me see where I can share my screen. Okay. Yeah, I hope this is visible.
Yep. Yep.
Okay, right. So that was a very good introduction, I think. Better than I could have done it. Um, right. So going into the 3 feet pool with Keras, what is Keras? Keras is a framework or a library that one can use to get started with machine learning. It was developed by Francois Chalet in 2015, and it started as a research project out of spite because he did not like TensorFlow and how difficult it was to start writing models in TensorFlow. So he decided might as well just write a new thing within TensorFlow to start training models on it. Slowly, he also added other backends to it like Piano, Cafe, MXNet, and others, but he left it aside later on in favor of just TensorFlow. The most important part being that it's fully free and open source. So why should you consider Keras as to be your first and last ML framework? Well, first off, a very large community built from the ground up. There are a ton of folks within the community that are always ready to help you out in any kind of problem solving endeavor that you're on with Keras. A very strong support for documentation. Keras Examples is one of the largest repositories of machine learning code for absolutely any kind of use case that you can think of. Production ready. Well, if you're using Keras and you're using TensorFlow as the main backend, you can directly use the TensorFlow extended ecosystem to go get your models from simple training and simple problem solving to large scale production with TensorFlow JS, TensorFlow Lite, TensorFlow Serving, and so much more. Lastly, it's extensible. It has its own layers, activations, and so much more. But if you want to create something new out of them, that is also very much possible with Keras. So that was a very short introduction to Keras. But what is Keras CV? For the ones who are beginning with Keras CV, well, it is a library of computer vision oriented tools that are written within Keras. And it supports the latest features like mixed precision training, XLA compilations, TPUs, and so much more. It is meant for everything, be it industry grade deployments through the TensorFlow extended ecosystem, be it something as simple as deploying a ML model on your mobile phone, edge devices, and so much more. And most importantly, all of these are pre-trained, so you do not need to worry about how you can train these models further on later. For the restless, for the ones who want to start building right away, there is support for Stable Diffusion, YOLO, CSV Darknet, EfficientNet, and so many more pre-trained models right off the bat. And other vision problems like image segmentation, object detection, and 3D vision are becoming first-class citizens of Keras CV as we speak. A modular API that allows you to mix and match the components from Keras CV along with Keras and Keras NLP, making for an integrated tool of development. And the extensive guides that I had mentioned back was a very important step in making this a complete feature-ready ecosystem. So that was Keras and Keras CV and what you can start doing with that. But let's dive right in. How do you actually look at Keras CV? Well, first off, Keras CV for image augmentations is awesome. You can get some of the most latest research-based augmentation techniques right out of the box, like augmix, cutmix, Fourier mix, and so much more. But if you're confused as to what I should use, well, you have rand augment. You can randomly choose augmentations on the fly using the rand augment layer. Not only that, you also have support for bounding boxes being handled within the augmentation layers at the same time. But let's say you want to work with object detection. You have full support for the YOLO V8 model and RetinaNet with others on its way. But not only 2D modality, you also can now perform 3D object detection using the models that are present within KerasCV with more in the pipeline. If you're looking for, let's say, image segmentation, you want to get each and every pixel and you want to assign a class to them. Well, rapid development is underway for supporting segmentation models which segment anything already on its way. And there are some powerful visualization APIs that already exist within KerasCV for image segmentation. For image generation, which is all the craze nowadays, you see that there is support for pre-trained stable diffusion that I had mentioned back before. But you also have some very extensive and beautiful guides as to how you can make it better with tools like textual inversion or Dream Booth from Hugging Face, and let your imagination run wild. So that was Keras CV, and that's what you can solve with Keras CV. But taking Keras CV for a spin is what we're going to be looking at next. I shall share the Colab notebook, but on the other hand, you can also follow along, or you can keep it for later, or just see me do it. So what we're going to be looking at is generating some very high fidelity images with stable diffusions. You can generate your own images. You can generate some very weird imaginations through stable diffusion. For example, what you can see right here is an astronaut sitting on a beach. That's pretty cool if you ask me. But yeah, let me see if I can get the notebook. links. Aha. So what I'm going to do in the interest of time is actually show you the weights and biases dashboard from previous exhibitions that I've had for this specific notebook. And I'll share the notebook aside as well. Um, Let me see. Right. Uh, First, I'd like to introduce the stabilization notebook. Let me see. Hmm. So, how can I drop it into the chat? Okay. Yeah. So I've dropped the notebook in the chat. I think you all should be able to access it as well. So, quick note of caution: you might want to restart your runtime after each and every notebook, each and every cell of the models, right? So, what we're doing here, this notebook is basically meant for checking stable diffusion and the different kinds of modes that are available within stable diffusion for Keras CV. So, the first few lines are just quite literally running the imports and getting everything installed and stuff like that. And using weights and biases just for logging all your results onto the dashboard. But if you want to look towards the actual code, as we can now probably see through the notebook, there are four different techniques that we are using for stable diffusion here. First off, there is XLA. XLA is a compiler for linear algebra, if you will. Using XLA, you can perform just-in-time compilation and speed up your models by orders of magnitude, maybe something around 8, 10, 14, 20, or even far more number of times faster. Along the same lines, you can also use mixed precision. When we talk about mixed precision, sorry, mixed precision is basically trying to use the variables that exist within the network, the weights and biases that exist as float 32 variables, as float 16 variables. What this does is dramatically reduce the size requirement of your network and bring it down from a 32-bit variable to a 16-bit variable. This might sound like a very small change, but when you do this across the entire network with over a billion parameters, it makes a significant difference in the size and the different kinds of outputs that you might get. So how do you actually do this? Well, if you want to run mixed precision, all you need to do is set this parameter right here. Keras mixed precision set global policy mix float 16. That's all. That's it. Setting that will allow your network to be in the float 16 paradigm. Let's say you want to use XArray. How do you go about that? Well, again, another single line. JIT compile equal to true. Passing that into your network definition will allow you to start running your network with XLA compilation. So going through both of them together, you'd see something like setting the backend to a float 16, setting up weights and biases, initializing the model with JIT compiled true. Setting stable diffusion requires you to warm up the model. Warming up the model is basically going to initialize all the variables, all the training weights, everything, and also ensure the XLA compilation runs so that when you're actually generating along a prompt, you get faster results. Then we just generate a sort of interesting image with this prompt: cheetah running behind a dog on a beach with a night sky and shining sea water. That's very innovative. You have something of that sort running through your network and generating those images. Lastly, you create those images and upload them to the weights and biases dashboard. And then you can just clear up your memory and finish the run on weights and biases. So looking at some results, what you see right here is the generation time it takes for with no kind of optimization, which I mean no XLA and no mixed precision. You'd see something like 287 seconds that it takes to generate just three images. 287 seconds is almost 4.5 minutes, if not 5 minutes. But on the other hand, if you just enable mixed precision, you go down right to 65 seconds. That's almost a 25% of what it originally took, a 75% improvement over the original space. If you enable XLA though, you reach to 110 seconds, which is almost 33% of what the original speed is. You go down to 110 seconds with just a single line of code, with no kind of drop in your performance of the model's accuracy. Lastly, if you enable both of them together, you go down to just 32 seconds, right from 287 seconds to just 32 seconds. That's almost 9 times better than what you were trying to do without any kind of optimization, just with two lines of code. But what do those images look like? Well, this is one of them. You'd have the cheetah running on the beach, or you'd have Batman and that's Superman and Supergirl. And on the other hand, you have, well, Wolverine trying to break a lock with his claws. Well, I don't see the lock, but yeah. And you have Petronas Twin Towers, well, two of them, of course, and different kinds of all generations that come around using this network. So yeah, that's basically what this notebook would do. So if you're interested, you can very well start using this notebook directly and get forward with it. Coming back to the slides, well, that's basically the idea around stable diffusion and how you can get started with it using Keras CV. So this was a very good introduction to how you can get started with Keras CV, Keras, and what computer vision is all about. If you are just getting started, I'd highly recommend looking at the Keras examples, PyMeth search towards data science, and other resources that exist within the Keras ecosystem and beyond for learning about computer vision. But if you are restless and you want to look towards building new stuff, well, the first principles of computer vision playlist on YouTube is a beautiful way to get started with computer vision and its core concepts. Along with that, you can look at the documentation within Keras CV and the Hugging Face computer vision tasks to get a good grip on the computer vision side of things. So that's it. That's us covering what was on the agenda for today. So thank you for having me, Kartikey, and great stuff right there.
Thank you so much, Suvaditya. By the way, I really love the talk, love your talk. Your stability
Thank you,
diffusion one part.
thank you.
Thank you for that. And yeah, sorry.
Yeah, so I think if there are any questions, I'd be happy to take them. That's absolutely fine. And if you want to connect with me, well, my Twitter in the chat. You can connect with me on Twitter, on LinkedIn, or any other such social media platforms. I'm available. I might take some time to get back, but I will get back. So feel free to reach
I
out.
will, I will, I will recommend everyone to follow Suvaditya. He's dropping a great content around on Twitter, and basically, in general, if anyone really damn interested in ML, do follow him for sure around it. Yeah, he will
That's
help you
very
in
kind.
a better way. Yeah. Okay, there's one question from you, Suvaditya. Do CNNs train on reward-based model, and how does that work in NLP? I thought they used RNN. Suvaditya, can you take that? Want to take that question?
Sure,
Yeah.
sure. Good question, first off. CNNs don't really look towards a reward-based model. Reward-based models are something more along used in the reinforcement learning domain. In NLP, yes, they do use RNNs. RNNs are more of a sequential model because you're looking to process sequences like text sentences and so on. If you're looking towards the vision transformer domain, there are approaches where images have been forcibly converted into sequences and passed using vision transformers or even vision RNNs and so on. So, I mean, if you're hacking around it, you can find solutions around CNNs, around computer vision models using images with RNNs. But it's not really a very recommended approach simply because of the computational inefficiencies. You'd see that CNNs almost always give a better result with, general against general architectures in comparison to, let's say, RNNs or something like that. On the other hand, if you're looking at like how CNNs train, they'd be more along the simple back, calculate the loss and just backprop across it. That basically most of how computer vision based neural networks work. So yeah, that's basically what we're looking at for CNNs.
Yeah, cool. I hope so. There is no more questions. Still, if you have any other doubts, you can again. I guess Swaditya is in Discord also. So if you have
Yeah,
anyone have any doubts, so they can you can say tag in the discussion channel and basically ask any question around it. Obviously,
thank you for having me. I'd love to, maybe interact with you all sometimes very soon in person as well. Um, it's a bit of a busy schedule for me. Otherwise, I would have tried to, come in person, but been a bit busy with everything else going around. And yeah, I mean, great session. I'd love to, see you all around sometime soon. Sure thing.
yeah. I think of maybe so they will come to DevFest, but he's not joining for us, so it's really disheartened for us, obviously. But literally, we want Swaditya, but due to his some commitments, maybe he's not able to join.
Yeah,
But we'll definitely do a
yeah,
meetup for sure. That's
for sure.
our take around it. Maybe on December or maybe on in initial early of January, we will try to do our best around it for sure.
Absolutely,
And
absolutely.
yeah, and I hope so you love the session. Thanks, Isha. Thanks, Isha. Thanks, Asmi. And thanks, Rex4563. If you have a name, I'm really sorry for that because I'm able to see that only. And yeah, see you soon on the next call and on the next meetup or on the next research paper reading. And yeah, maybe in the next part, you can say. So yeah, see ya, folks. Bye bye.